Hey guys, thanks for tuning in to another episode of Jack's Mechanics. Got a Toyota Kluger here, not sure what year. I'm pretty sure it might be a GSU 40, 2GRFE. Literally just jumped into it. The customer is a new customer, so I've never seen this guy, never worked on this car before. Obviously got the check engine light on and traction light. His main concern is the engine light, and apparently it's been on for a couple of years, been to a few shops, no one's been able to fix it. He said it was for an O2 sensor, so I guess we'll plug the scan tool in and have a look at that one. Alrighty, so it's 2009 model GSU 40 and it is a 2GRFE 3.5 litre V6 petrol. We'll just go into the EOBD and have a look at these fault codes. 231,000 Ks on this thing. Oh, it's not an O2 sensor fault. There you go. Alright, well, hopefully this is straightforward. We'll go back. Everything seems to be lean. Have a look at these fuel trims as per normal. Close through. As you can see, engine's still warming up. 4 grams of airflow, and the aircon's on, so that will always bring it up a little bit. The barrow, I mean, it should be about 101 around here. Shouldn't be too much of an issue. Okay, yeah. Definitely running lean. The numbers down the bottom, these two, long term, basically it's memory fuel trims. Short term should always be pretty close to zero. That'll be dependent on how much fuel correction the manufacturer allows the ECU to make. So it's definitely running lean. Obviously, as per usual, our first check if this is going to be a potential vacuum leak. We're going to raise the RPM somewhere between 2,000 and 3,000 and watch the fuel trims. It's 1,500. It's 2,000. It's 2,500. Not really changing that much. We do have data updating, so you can see the graph is ticking by. Not really looking like an O2 sensor fault. Sorry, a vacuum leak fault. Interesting. Okay. Honestly, I think I might just pull the mass airflow sensor out and just have a look at it. Could take it for a drive and do or somebody's definitely been working on this 1,200 since the DTCs were cleared, distance while mill active. So they cleared him. 2 kilometers later, came back on. Number of warm-ups since DTC's cleared, 95. It's got wide bands up the front by the looks of things. You know, and they should be around 1, and that's the reading in lambda. Alright, I think, yeah, just for interest's sake, I might just pull out the mass airflow sensor and just take a look. It's going to be a quick, next easy test. Failing that, then I think we'll do a volumetric efficiency test on there, and also have a look at the O2 sensors, what they're reading. But like under drive, under load, see what they're doing. So I pulled the mass airflow sensor out, just had a quick look over it. I did just give it a quick clean, but it's not that dirty at all. Try and get you focused in on that. My hand is so shaky right now. That might be better. They look a bit bent. I'm not sure how much I like that, but yeah, they're definitely clean. So chuck them back in. And we'll go for a test drive and have a look at the O2 sensors under a wide open throttle pull and see if we've got a fuel delivery issue. So I was just thinking, something I didn't consider is probably checking the brake booster. I'm not sure if I was just sitting there with my foot on the brake. Obviously that would introduce a vacuum leak. So yeah, not sure if it would change with, I would expect it to change with RPM and sort of go away, but better to be safe than sorry, realistically. So I've just got the brake booster line clamped off, and I'll just go check those fuel trims now. So we're just on the road. We've got our EQ ratios down the bottom there. Bank 2 sensor 1, bank 1 sensor 1. Going to do basically a wide open pull, and we want to see it drop low. It's opposite to a narrow band sensor. We want to see that go down probably to around 600, maybe 700. And yeah, so I'm going to do that now. The brake booster check showed nothing, so as we sort of assumed it would, but you know, better to check. I've been caught out before with strange things, so obviously can't record this, but I'll show you the data afterwards. Okay, so we are on track finding our issue right here. Obviously you can see our max, both the same, 1.232. That's very lean, and obviously that's on a wider open throttle pull. I'll just pause the capture so we can see what's going on. You can see up the top here our airflow rate is increasing, and here we want to see this going down, adding fuel, but there's no fuel delivery. You can see also on that's the O2 sensor, the bank 1 and 2 sensor 2 at this point here also dropped very lean, so absolutely a lean condition. Looks like some a fuel delivery condition, or maybe an over reporting airflow sensor. 171 grams per second, max at 5,000 RPM. To me that sounds a bit high just off the top of my head. So I'll show you how we do a volumetric efficiency test and see if this thing's over reporting. If that comes back good, we're going to look at the fuel delivery side, maybe the fuel pump, maybe the injectors, and yeah. Okay, so these are the 4 PIDs that we want up: airspeed, air temp, airflow, engine speed, I meant to say there, engine speed, air temp, airflow, barometric pressure. So next step, we're lined up and we're just going to do a full speed engine pull, pretty much up to the red line, first gear. Once it's done first gear, we'll just let it roll out, and we'll grab the numbers, we'll punch them into the computer. Our VE calculator, we use a website called The Automotive Technician. It's a yearly subscription. Highly recommend you guys who are watching this check it out, just for these sort of things. Super worth it. There is a yearly cost, about $250, but it is way worth it. So I'll do this pull and we'll get these numbers, we'll punch it into the computer and see what it comes up with. So we've got our numbers here, 5,000 and 5,600 RPM. I was looking on the tacho and it was pretty close to that. Obviously we have our custom PID list, so we have our fastest refresh rate possible for the scanner. You want to do this for accuracy. Intake air temp, around 50 odd degrees. Airflow, max airflow 178.6 grams per second, and obviously got our barrow down the bottom there. So I'll just show you how quick this is moving along now with the custom PID list. See, that's why you want to set a custom PID list. Really responsive. You need accuracy when you're doing this sort of thing. So we'll go back to the shop and I'll punch these numbers in the computer and see what it comes up with. So I misspoke in the last clip of the video, saying that an over-reporting mass airflow sensor would give a lean condition, and it's actually the opposite way around. So I'm just at home, I was just editing it and realized that, so I just wanted to clarify basically my test of doing the volumetric efficiency test. I guess good to confirm that it's okay. Make sure that the mass airflow sensor was reading correctly. At 180 grams for an engine like that, it's probably in the ballpark range. It's nothing massively over and nothing massively under, which is really what we're worried about. A slight skew isn't really going to worry it too much. So I've just got this here. So if we had a under-reporting mass airflow sensor reading roughly, we just use round numbers, 100 grams of airflow at wide open throttle, but our actual airflow is 150, which is why it's under-reporting. It's not reading all the air. That may be from a failing sensor or a dirty sensor, maybe resistance in the signal wire, I guess even potentially a bad PCM, obviously a bad mass airflow sensor itself, circuitry inside there. So if we had 150 grams actually entering the engine, but only 100 of it being read, that means the fuel delivery is being delivered for 100 grams. So when it gets to the exhaust, there's obviously a lot of extra air rather than perfect, close enough to stoichiometric ratio. So because the exhaust is reading lean with the O2 sensors, which is in our case, we have lean codes with a positive fuel trim. So if our mass airflow sensor was like reading really low, sorry, I just had to pause the recording there. My son was coming screaming down the hallway. So yeah, we would have lean exhaust, which would give us lean codes. The O2 sensors are reading a lean condition, which gives us positive fuel trims, which is what we've got in our case. The fact that in our video, we were like 20 grams above means that the mass airflow sensor really cannot be the issue. On the opposite side, we have an over-reporting mass airflow sensor. We have actual airflow grams again of 150, just using round numbers. And let's say it's reporting 200 grams. Again, the fuel is delivered for 200 grams. So when it gets down to the exhaust, obviously we have a rich condition. There's not enough air delivered for the amount of fuel that's being delivered. The O2 sensors see that and it starts pulling fuel away. And you see that fuel trims go negative. And when you see a negative fuel trim, you get rich codes. So just sort of wanted to clarify that again. I did have a recording while I was at work, but it was messy, and this way just seems to be a bit easier. If you guys have any questions, drop them in the comments. I'll do my best to explain them. But yeah, just you can even have a look over this again. Pause the video if you like, and just read it. And hope this helps, and I hope you guys are enjoying the videos. So we've got the fuel pressure gauge hooked up. Obviously we're in between 20 and 25 psi. You know, let's just call it 22, 23, and basically the spec for this thing is 44 psi at idle, at a minimal. It doesn't have any flow because it's returnless system. I've just got that teed in down the bottom there. Was going to see if we could look at our fuel pump amperage and waveform, but unfortunately I don't have a relay buddy or the U-activate yet, which is still coming from AES wave. So there's no fuse that I can find in the engine bay for this fuel pump either. So just going to basically put a fuel pump in this thing. You know, that's just screaming fuel pump or just some potential blockage. With this many Ks, it's very likely it's never been changed. Their fuel pumps, there's unfortunately none local, so we'll get one within the next couple of days and get it in and retest it and show you the fix. So a few days later, got this Kluger back. This is the fuel pump for it. This strainer down the bottom is looking pretty blocked, which is obviously not good. Looks like we've got a little filter element here. It's got a bit of weight to it. Definitely more than the new one that we're going to install. We obviously checked power and grounds at the pump and they were good, and took an amperage measurement reading. It was only actually pulling 3 amps, so going to take another reading of that once we've got the new pump in, and obviously we'll check our scan data and that again and just confirm everything's all good. Take it for a drive, and this one should be fixed not too far away, though it is next week for us. Luckily for us, this customer filled the tank completely as they always do. The job's not too bad. Pull the seat out and get through the inspection cover, and the top nut and everything needs to be replaced as part of the job, so that's all getting done. So we'll get it back together and take some more voltage measurements and yeah, go from there. New fuel pump in, guys. Our minimum spec was 44 psi idle. Obviously just above that, maybe like 47 psi. Hooked in where we were before, couldn't get it hooked in at the tank. Took another amperage reading, 3.6 amps this pump's pulling, genuine Denso pump. I would have thought maybe with the blockage on the other one that it should be pulling more amps, but yeah, not too sure why that may be. Didn't obviously get to put the scope on it or anything like that, so maybe a segment was worn and maybe that was what causes lower amperage, but I'm just sort of speculating. If anybody can, you know, maybe clear that up with me, that'd be great. Help everybody else out here. Check down in the comments if anybody's commented, and maybe we can all learn a bit extra. But as for this one, absolutely looking like a fix. Really running out of time today, doing a clutch on a D-Max at the same time while co-worker fitted up this fuel pump. So we might have a look at scan data, maybe not, but you know, we've got some fuel pressure readings and we can pretty much confirm this is going to be right. So thanks for following us on that one, guys. If it helped you out, please consider liking the video and subscribing to the channel for more of this sort of stuff, and yeah, we'll see you in the next one. Take care.